Hi, welcome back to my channel. This is Venky. Today I would like to explain Newton's first law of motion with some good examples. Apart from discussing the law, I also would like to talk about how this law of motion can be applied to objects like planets that are moving in the outer space. So let's first see what the law states. The law states that an object at rest will always be at rest until a force acts upon it. So if you keep a football in the ground, until you kick, the ball will remain in the same position. This is the first part of the law. This law has got two parts. The second part of the law is, I would say, the most interesting part. The law states that an object in motion will always be in motion until a force acts upon it. So this discussion is going to be around the second part of this law. This law is also called as the law of inertia. So let me try to give you some examples for the law of inertia and explain this law. Assume you are rolling a ball in the ground. The ball would stop after traveling a certain distance. So why does the ball stop? This is because there are other forces that act on the ball, like friction, air, that stop the ball. But if you throw a ball in an empty space, outer space, outside Earth's atmosphere, where no other forces can act on it, the ball would literally keep moving on and on and on without stopping. This is what the second part of the law of motion is all about. The ball will keep moving at the same motion and direction at which it was originally thrown. The ball will have a tendency to resist change to the speed and direction of movement. This tendency to resist change is called inertia, and this is what the second part of the law of inertia states. The ball will have no change in its state of motion. Now this is a simple example to explain the law of motion. A real illustration of this law of motion is the objects in the outer space having a constant motion. Example, Earth keeps moving around the sun at a constant motion. This is because of inertia, because there are no other forces like friction or air that could stop these objects in the outer space. Now let's discuss a bit more on inertia, the importance of inertia. We saw what is inertia, but why is inertia so important? The inertia of the planets is so vital for the universe to function. Why? The answer is, it's the interaction of inertia and the gravity that keeps the planets stay in a stable orbit without colliding with each other. The inertia of the moon and the gravity of the earth keeps moon in its orbit around the earth. The inertia of the earth and the gravity of the sun keeps earth stay in its orbit around the sun. For the same reason, the satellites are kept in their orbits around the earth. Let's see a quick illustration. Watch this. Imagine that the blue ball is the earth and red ball is the sun. Earth keeps moving on and on and on around the sun like this. Now there is no force in the outer space that can stop the movement, the motion and direction of Earth's movement around the sun. Now this constant motion of Earth is called the inertia. Now the question is, why does Earth not go away from the sun? If Earth is moving because of inertia, then it must be going in a straight line like this, right? It is the gravity of the sun that doesn't let Earth go away from sun. Earth keeps going like this, but the gravity of the sun pulls down Earth and it does not let Earth go away from its orbit, and Earth keeps moving around the sun. So as you can see, there is a balance between the motion of Earth and the gravitational force from the sun. This interaction of inertia of the Earth and the gravity from the sun is what prevents collision of Earth and sun. So inertia is really critical for objects to be in their orbit. Now imagine if there is no inertia, there is only gravity. Disastrous. Moon will collide with Earth because the gravity of Earth will just pull Moon down. Similarly, the gravity of the sun will just pull Earth down and cause a collision. This is what will happen when there is zero inertia. Earth will not be in motion. The gravity of the sun will just pull Earth down and cause a collision. Now let's imagine the other way around. Gravity is the force that connects everything in this universe. Now imagine there is only inertia, no gravity at all. Moon would just travel away from the Earth, and Earth would travel away from the sun. All the planets would just go outside the solar system if there is no force of gravity to control them. If Sun's force of gravity is not there, then Earth would just travel in a straight line and go away from the Sun. It is the Sun's force of gravity that alters its course, causing Earth to travel in a circular direction around the Sun. So the interaction of inertia and gravity is vital for the universe to function because it keeps the planets in a stable orbit without colliding with each other. And this principle of inertia can be applied on satellites as well that orbit around the Earth. Satellites are set in motion in their orbits at a calculated speed. Then it's the inertia that keeps them at a constant motion. Satellites move at the same speed and direction around the Earth. The interaction of inertia of the satellites and the gravity of the Earth keeps the satellites stay in a stable orbit around the Earth. Before I conclude this topic of inertia, the law of motion, I would like to tell you something else, though it's not directly related to the law of motion. I mentioned that planets move at a constant speed. So the question that must be running in your mind is, what caused the initial motion of the planets? If planets are moving, there must be something that should have triggered the motion of the planets. So if Earth is moving, what caused the initial velocity of Earth? To answer this, we need to travel back in time 13.8 billion years ago when Big Bang happened. Masses were thrown away at a force during Big Bang, and some of these masses were brought together with each other by the force of gravity, causing the formation of Earth. Now, this is a very, very simple way to explain the formation of Earth. But the point here is that it could have been many sources: collision with other bodies, the energy from the Big Bang that could have triggered the initial motion of the masses in the outer space. This is the reason for the constant motion of Earth and other objects in the solar system. Thanks for watching this video. Hope you find it informative.